Hey everybody, this is Mrs. Hilt, when we are going to be going through quantum numbers and atomic orbitals. We left off talking about emission spectra and did calculations with finding energy using the difference or the changes in energy levels when electrons jump between them. Now we're going to look at the energy levels and use the different coordinates of an atom on the periodic table to help us identify the potential locations of the electrons within the atom. So, all right, so we have all of these Bohr models right here. All of these shells that are surrounding the nucleus, these are the energy levels that we're talking about. And those little dots, those are our electrons, and when they jump between those levels, that is when they either absorb or emit energy. So the Bohr model is a good representation when you're trying to perform calculations like we were with determining the energy when electrons jump between the energy levels. However, the quantum mechanical model is a much better representation of what the atom actually looks like, or the area that an electron can live within the atom. And we use different quantum numbers to help us identify where exactly the electrons are flying around, depending on the atom and depending on the number of electrons. So comparing the two models, for the Bohr model, electrons are only found in circular paths, like an orbit around the nucleus. And it looks like it is a fixed orbit, but it's just intended to be a fixed energy level. And we can calculate how much energy it takes to jump between those. The quantum mechanical model is just an idea that helps us predict the location of an electron. It's based off of the Schrodinger equation, which involves quite a bit of intense math. We're not going to do that in this class, so we'll just use the quantum numbers to help us make these predictions. Another good example of what the electrons look like in an atom is describing their location as a cloud, just flying around like crazy, and it just looks almost like Pigpen's head with a bunch of gnats flying all around it. Okay, so where are these electrons? Electrons exist in orbitals, and this is per the quantum mechanical model. And the orbital just describes, again, the most likely location that we'll find the electron within the atom. So these are all examples of orbitals, all those bright colored shapes. So these are potential locations that we could find an electron within an atom. Now, how we identify which one of those colored shapes and which direction it is facing, we use the quantum numbers. There are 4 quantum numbers, N, L, and I wrote a cursive L because later in the slides I switched to cursive because I started to think that that looked like a capital I, M sub L, and M sub S. Each of these build off each other. So once you get N, you have all of the tools to figure out all of the ones that come after it. Okay, so first up is N. So N is the principal quantum number, and N tells us the specific energy level that an electron could live in. We determine the N value based on the period that the atom is in on the periodic table. Because there are only 7 periods on the periodic table, the only numbers that you could have for N are 1 through 7. And this is also a range. So if we have an atom that is in period 4, it can have electrons in the 4th energy level, in the 3rd energy level, 2nd, and the 1st, which is really well represented by the Bohr model. Next up, after we identify the N, we can now identify the sublevel, or once we have the energy level, we can identify the sublevel of that energy level. And this helps us to identify the shape that the electrons may be found in. I'm going to jump back to that slide again. So we have circle, dumbbell, double dumbbell, and then triple dumbbell. So those are all the different shapes that electrons could live in. And how we figure out which shape, and all of those different colors are related to these letters. So that one at the top that was red would be S. The next one down, P, D, and F. Okay, but how we find which shape is by taking the n value and subtracting 1. This, just like the n, is a range, however. So if we have an atom that is in period 2, therefore has a quantum or principal quantum number of 2, n equals 2, that means that its possible L values would be 2 minus 1, which is 1, and it would be anything from 0 to 1. So the two shapes that an atom that lives in period 2 could have its electrons living in are in the S sublevel or the P sublevel. So one of those ones. All right, now that we know how to identify the n value and what shape it is in, now we need to figure out which specific angle that the electron will be set in. All right, and that brings us to the m sub L, or the magnetic quantum number. So this tells us the orientation, and how we find this is by taking the L value, and the m sub L is equal to negative L to positive L. Okay, so it's a range, just think of like a range on a number line. So for example, the P sublevel, that means that our L value is equal to 1. Therefore, our m sub L is anything from negative 1, 0 to positive 1. So that means that within the P sublevel, there are 3 possible p orbitals. Right. So organization of these levels, the shell is the same as the energy level. Right? We already talked about that, which is determined based on the period. Sublevels are letters, and then orbitals, or an orbital, is each individual block within the sublevel. So that was determined by the m sub L. So if you have that L equals 1, ML is equal to negative 1, 0, plus 1, and how we said there's 3 p orbitals. That's why there are 3 p orbitals in this diagram. Brings us to our last quantum number, and that is m sub s. So the m sub s tells us that within one orbital, we have 2 electrons, and one of them is going to be spinning up, and it will have a value of positive 1/2, and the other one is spinning down, the negative 1/2. And how we will represent that is by drawing arrows, arrow up, arrow down, and well, this one I did half arrows, or you can do whole arrows, not that big of a deal. And the reason why we have one spinning up, one spinning down is due to the Pauli exclusion principle. It tells us that no 2 electrons in an atom can have the same 4 quantum numbers. So they can have the same n, L, m sub L, but when they get to the m sub s, one electron will be spinning one direction and one will be spinning the other. We'll get into more of this principle in just a few slides. All right, so we are going to break these down with our example of calcium. Zoom in on the periodic table. So calcium is right here, number 20, and it is in period 4. That means that calcium, since it's in period 4, has the highest energy, or has the energy level of 4. Its highest energy level is 4. From that, we can calculate the possible L values. And because we find L by taking n minus 1, and it is a range, so 0 to n minus 1, our possible L values are anywhere from 0 to 3. Now remember, those correlate directly or tell us which sublevel the electrons are living in. Now here are all of our m sub L values that we found from our L values. And the total number of orbitals is based on the total number of digits that we have found for m sub L. Then the number of electrons that we have that can exist in each of those, because 2 electrons exist in each orbital, the number of electrons just doubles. So if we have 1 orbital, there's 2 electrons, 3 orbitals, there's 6, and so on. All right, let's do a little recap. So electrons in the same shell have the same N value. Electrons in the same subshell have the same N and L value. Electrons in the same orbital have the same N, L, and M sub L values, but only a maximum of 2 electrons can have all 3 of those values the same. Then no 2 electrons can have all 4 of the same. Like I was saying earlier, the M sub S, that will be different because one will have a positive spin or spin up, and the other will be down. All right, so let's compare these S, P, D, and Fs to the periodic table. Okay, so S block right over here, P, D, and F. So when you are identifying where the electrons live for certain atoms, you might not have any electrons that live in the D block just because the atom that you are focusing on is either in period 1 or period 2. All right, so now how we are placing these electrons in different orbitals is based on the different energies that these orbitals have. This is a chart that you guys will fill in, and when you fill it in, you write in electrons, just like how you saw arrows drawn before, just like that. But we have to go over some principles as to how these actually get filled in. So first one, energy levels are filled in from the lowest possible energy level, and you work your way up. That is the Aufbau principle. Okay? That's why it's really nice to use this chart. And if you know the total number of electrons, you can just be filling it in, just kind of like how you would walk up a staircase, one step at a time, one energy level at a time. Then we have the Pauli exclusion principle, and that means that 2 electrons in the same orbital, they must have opposite spins. So that's why we have one spinning up, one spinning down, or arrows pointing opposite ways to represent that. And lastly is Hund's rule. Hund's rule tells us that electrons only pair up when every orbital of the same energy level or sublevel has 1 electron in it. Think of this as when you are filling in the electrons, kind of like how kids get on a school bus. They will fill in seats until all of the seats are filled up. Then they start doubling up until it's all full. Then they got to move on to the next bus. Of course, I should have started down here and worked my way up, but that was just a quick example. Okay, and when you are filling in those electrons, you have to keep the same spin until each orbital has 1 electron. That's why I drew one arrow pointing up in each of them and then went back and drew an arrow pointing down to show the opposite spin. All right, let's get some examples. So I'm definitely going to be doing this first one for you. That is nickel. And for each of these are all going to be atoms. Therefore, they are electrically neutral. So they have the same number of protons as they do electrons. Nickel will be our first one. It is in period 4, 28 electrons because of 28 protons. Arsenic is after, also period 4. Strontium is the last one in period 5. All right, so again, nickel, 28 electrons, and based on its location, we know that it is in energy level 4. So we will end up with electrons in energy level 4, so any of these 4p's we'll get to which sublevel that we'll actually end in based on the L values. Let's fill in these electrons and work from there. All right, spin up, spin down, energy level up, spin up, spin down. Now fill it in again, just like kids on a school bus. Okay, I'm at 2, 4, 6, 8, 10 electrons. 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, and that's it. All right, so here are all of the possible energy levels, sublevels, and orbitals that electrons within a nickel atom could live. Now let's identify the different parts. I'm going to pick an electron. Let's pick the very last one that we ended in, because why not? Highlight, that's a little too big. All right, so let's identify the 4 quantum numbers associated with that electron I just highlighted. All right, we are going to start with N. So when N is, because this ended up in the 3rd energy level, and I know that because of the 3 right there, our N is equal to 3. Now our L, because we are in the D sublevel, that tells us that our L value is equal to 2. Now if we had been in, excuse me, the P sublevel, L would have been equal to 1. Had we been in the S sublevel, L would be equal to 0. And how I know that is based on that chart back on slide number 12. I think it was slide number 12. Sorry if it's not. All right. Now our sub L value, we find this by taking negative L to positive L. And how that will look on your chart is like this. M sub L, anywhere from negative L to positive L. And how I know where to plug these in or right underneath the different letters and numbers is just by filling it in sequentially. So think of this as a number line. Start with the lowest and work your way up. So this tells us that our electron is in this orbital right here. Our M sub L is 0 because our electron is in the orbital right there. Let's write that in. Okay, and then the M sub S, that arrow is pointing down, so we have a negative 1/2 spin. There we go. Some color coordination going on. Okay, let's do this for another electron in here, just for practice. So let's try, actually let's go about it the backwards way. I'm going to give the quantum numbers, and then we will identify which electron it is. So if we have N is equal to 2, all right, so we have N is equal to 2 is our principal quantum number. So that tells us that our electron is somewhere in the in the 2nd energy level. So it could be any one of these. And to identify specifically which sublevel it's in, we have to look at L. When L equals 0, we are in the S sublevel. Then our orbital, because the S sublevel only has one orbital, we already know exactly which one it is in. And finally, our spin, positive 1/2, therefore we are spinning upwards. Draw some lines connecting those. All right. Let's get some more practice. All right, let's try arsenic. Now, if you're feeling confident, pause the video and fill in arsenic for yourself. When you're ready for the answers, press play. All right, so here's what you would have gotten after filling in all of the electrons for arsenic. And I hope that you guys noticed that the 3D sublevel, it's a little odd. It comes after the 4S, or 4S comes before 3D. And that is based on the different blocks that I showed you guys on the periodic table, and just how this third level, or this 3D level, it has a lot more energy in it. So when we fill it in, we can only fill energy level, or go up the energy levels, and it. All right, let's try identifying the electrons based on these quantum numbers. So if you're feeling confident, go ahead and try that out on your own. Otherwise, I'm going to start going over it in 3, 2, 1. Okay, so starting over here, and we're going to start off, or we're going to do these ones together because they have very similar quantum numbers. So we have n equals 4. That means that we have electrons, or it is one of these electrons, because these are the only electrons right now in the 4th energy level. Then our L is equal to 1. That tells us that we are in the P sublevel. Okay, so that means it will be one of these ones. Then the M sub L, again, we will look at this like a number line with the M sub L. So -1, 0, 1, because that's determined from negative L to positive L. And since we have a -1, it's right here, and 0 there, these are the orbitals in which we can find the electrons for this one, -1, and this one, 0. And both of these have a positive 1/2 spin because both of those electrons are spinning upward or pointing upward. All right, now if you haven't tried one out on yourself, try solving this one. When you're ready for the answers, press play. All right, let's go through this. So we have energy level 2, because n equals 2. It is some or one of the electrons in this that I just circled. Because L is equal to 1, we are again in the P sublevel. Right, so it is one of these ones. Okay. The M sub L values that we used up here, I can duplicate those, bring them down, because it is still a P sublevel, so it will have the same M sub L values. Which one it is specifically is the +1. All right, and then the spin is -1/2, therefore it is spinning downward. All right, let's do another example. Okay, so this one we are doing strontium. So first, fill in all the electrons. Make sure that you are going in energy level order based on increasing energy, not necessarily the numbers. Once you have all your electrons filled in, Identify which electrons have these quantum numbers. When you are ready for the answers, press play. All right, let's check your work. All right, so first check all of your arrows or all of your electrons and make sure that they are in the correct spot. Then the first one, or the one to the left, this one will be the electron right here. It is spinning down, that's why it's negative 1/2. There is only one orbital in the S sublevel. That's why both L and ML are 0, and it is in the third energy level. Then our other one, fourth energy level, therefore that's why it is up in this region. L is equal to 1, so we are in the P sublevel. ML is -1, so that it is this specific orbital, and the M sub S is positive 1/2, so it is spinning up. All right, you guys are going to get some more practice with this. Please let me know if you have any questions.